Hi, welcome. This is just a quick review for what is expected for exam 3. So understanding the step function, the impulse or Dirac delta function, being able to analyze in the frequency domain. So that means being able to manipulate complex numbers, also being able to manipulate equations with an S domain, which is the same thing except for S is more generic, where S equals J omega is going to be a more specific result. Being able to do node voltage, Thevenin equivalence, superposition, Ohm's law, KVL, KCL, and then being able to convert the signal portion, which would be a phasor, into the frequency domain and then out of the frequency domain. So a couple reviews on that type of complex manipulation is being able to convert from rectangular and polar coordinates. So if you have an expression and you want to add and subtract, you're going to want to use rectangular form. So this is going to be for add and subtract. And then for multiply and divide, you're going to use the rectangular form. And so phasor form, to get the phasor, you need it to be in the time domain, a cosine, and in the frequency domain, you need it to be a phasor. Typically for Thevenin, you're going to want to have the impedance, ZTH, in rectangular form. And that is so that you can identify what elements are going to be in that Thevenin equivalence. So if you were to actually model it with those elements, you could then you could actually draw that circuit and connect it to a load and kind of see how it responds. VTH is going to be in polar form, again, because that's a signal. Transferring between each one, if you're already in rectangular and you want to go to polar, so from rectangular to polar, you're going to use these two, and if you're doing from polar to rectangular, it's going to be this form. So you use cosine and sine. So those are the conversions there. A couple other handy ones to remember is that J is equal to E to the J90, and a minus J is equal to EJ minus 90. So those are very helpful. J squared is going to be 1, or negative 1. When you have the properties of multiplication of polar, so say I have two polar forms, and say I'm multiplying them together, then that is going to be R1 times R2, and then you add the exponents. If you divide, that is going to result in the magnitude R3, R4, or R3 over R4, and then this is going to be a subtraction of the angles instead. When you add, you're going to add the real portions, and then you're going to add or subtract the imaginary portions. So these are all kind of a quick review of some properties that you just want to remember. The other concept to make sure you understand step functions. So step function is defined such as this, that below 0, it's going to be 0, and then at time 0, that's when something turns on, is most of the time what we're modeling. This, and then it's going to be the value of the magnitude in front of u of t, or the signal in front of ut. So 5 u of t is going to look like this. 8 ut minus 3, meaning it has a shift, is going to look like this one. The other function is that impulse or direct delta. And this one, again, has a magnitude to it. So like 7 delta t is going to be a spike at 0 with a magnitude of 7. And then it can also be shifted. So these are a quick review of just kind of the expectations of what's on the exam, along with some of the properties and functions.